Welcome back. This is Nick Agram once again. I will be discussing arithmetic series, and it is very related to arithmetic sequences or arithmetic progression. So if you missed my lecture on that, please go back to my previous videos. And I'm going to give anyway a brief repetition here. So for example, or review, we have 1, and then we have 4, and then we have 7, and then we have 10. We know that the difference is plus 3 there, plus 3, plus 3. Then if we have the same difference for all the terms, then we call it arithmetic sequence. And actually this is what we did. We have u sub 1, and then the second term should be u sub 1 plus d. So we have 1 plus 3 and 4. That's 4. And then you have u sub 1. The third term will be u sub 1 plus 2d. So 6 plus 1, that's 7. And then u sub 1 plus 3d. And so on. U sub 1 plus n minus 1 d. This is what we did before for our a sub n. This is u sub 1, this is u sub 2, u sub 3, u sub 4. So u sub 1, u sub 2, u sub 3, u sub 4. As you can see, when I have 3 there, and I have a subscript of 4, that's why we got u sub n here, and my subscript is n, but the number that I'm multiplying with d, the difference is 1 less than my subscript. Okay, that's good to know. Okay, the sum of a finite arithmetic series with first term u sub 1, common difference d, and last term un is that one. This is the formula where we can find the sum of an arithmetic series, finite arithmetic series. Okay, so to prove this formulas, I'm going to use an example, the same example that we have a while ago. We have, but I will start with 4, 7, 10, and then we have 13, and then we have 16, and then we have 19. Okay, remember that I can use this one for my 4, that is 4 plus 0. For my 7, we have 4 plus 3. For my 10, we have 4 plus 3 times 2. This is times 1. That 0 there actually is 3 times 0. But for 19, I can also use this 19. No, another pen, so that you can see the difference. For 19, I can use, this is 0. Okay. I have also 19 minus 3 times 0. For 16, I can have 19 minus 3 times 1 times 1. Oh, sorry. I'm using the Swedish way of. For 13, then we have 19 minus 3 times 2. So I have two ways in writing this. This is our blue. So that you will not get confused. This one now can be used as u sub 1. This is now u sub 1 plus 1 times the difference, u sub 2 1 at 2 times the difference. And for this one, we have u sub n minus 2 times the difference, u sub n minus the difference, and then u sub n. To generalize more, this one can be written by u sub 1 plus 2 minus 1 times the difference, u sub 1 plus 3 minus 1 times the difference. Here, you can write this. Oh, sorry, it should be red. U sub n plus 3 minus 1 d. Oh no, 0 minus. It should be minus there. And this one is u sub n minus 2 minus 1, the difference, and you have u sub n. Okay, so if we have now u sub 1 plus into u sub. We have a sequence u sub 1, u sub 2, u sub 3, u sub n minus 1, n minus 2, let's say, and then u sub n minus 1, and then u sub n. If we have that, then we can find the sum of this. The sum of that is, we have s sub n is equal to u sub 1 plus u sub 2 plus u sub 3 plus u sub n minus 1 plus u sub n minus 2 first, minus 1 plus u sub n. If we expand by using all of this now, we have u sub 1, u sub 2 will become u sub 1 plus d, u sub 3 will become u sub 1 plus 2d plus. And then if we're going to use this now, this, we have u sub n minus 2d plus u sub n minus d plus u sub n. This is our s sub n. It doesn't matter if I'm going to add here. It doesn't matter if I'm going to add this way. I will use this s sub 9 here, 6, sorry, not 9. I only have 6. It doesn't matter if I'm going to add this way. 4 plus 7 plus 10 plus 13 plus 16 plus 19. Or I'm going to add this way. 19 plus 16 plus 13 plus 10 plus 7 plus 4. It doesn't matter. That is what I am trying to use here. So s sub n can be written also as u sub n plus u sub n minus d plus u sub n minus 2d plus u sub 1 plus 2d plus u sub 1 plus d plus u sub 1. I just took the reverse. So if I'm going to add this, so I have 2 s sub n, then I have u sub 1 plus u sub n, these two, and then I have another u sub 1 plus u sub n, these two, but this will become 0, and it will continue. This is 0 also, plus u sub 1 plus u sub n plus u sub 1 plus u sub n plus u sub 1 plus u sub n. Okay, this is also 0. That's 0. Okay. Now, if I'm going to collect all my u sub 1, maybe I'm going to change to another pen. U sub 1 plus U sub 2, U sub 1 plus U sub 1 plus U sub 1 plus U sub 1. How many? 1, 2, 3. Plus U sub 1. That's my U sub 1. And my U sub 2, U sub n. U sub n plus 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 U sub n. You understood. That means the sum of this is n term U sub 1 plus n term U sub n. Common factor, we have n times U sub 1 plus U sub n. That is 2Sn. Okay? And then if we divide both sides of the equation by 2, then we have S sub n is equal to n divided by 2, or 0.5 if you want, U sub 1 plus U sub n. Then we found this equation, or that formula. How can we find the next one? We know that U sub n, this one, so like what I pointed a while ago, U sub n is the same as 1 plus n minus 1 d. Okay, so we have now, if we expand this now, we have n divided by 2 multiplied by U sub 1, and U sub n is U sub 1 plus n minus 1 times d. Or my bracket is better. Then we have now 2 U sub 1, so we have n divided by 2 times 2 U sub 1 plus n minus 1 times d. Then we got this also. Okay, remember this formula. And in my next video, I will be discussing some examples. For example, this one. Okay? I hope you learned something in my discussion on how to prove the formula for finding the sum of arithmetic series. And if you like what I'm doing, please subscribe or give a donation. Have a nice day.